We're on problem 99. And I like these that don't have a lot of words in them. M does not equal n. We have to prove that. Is it true that m does not equal n? Statement number 1 says that m plus n is less than 0. Well, let's see. What does this tell us? This just tells us that m is less than negative n. It still doesn't tell us anything. I mean, maybe negative n is, well, let's say if m is equal to n, which is equal to 10, is equal to negative 10, then this would hold true, right? Because negative 10 plus negative 10 is minus 20, which is less than 0. So this still doesn't prove anything. Or, of course, I could have two different numbers. I could have m being minus 5 and n being minus 1. And when you add them together, you get minus 6, both less than 0. So it still doesn't tell us anything whether m does not equal n. Statement 2. m times n is less than 0. Now, this is interesting. M times n is less than 0. So that tells us that 1 is positive and 1 is negative. Right? The only way you can multiply two numbers and get something less than 0 is one positive, and one negative. Right? And it doesn't say equal 0, so they both can equal 0. And so when you multiply two numbers and you get a negative number, they have to be different numbers, because one has to be positive and one has to be negative. Try it out with as many things as you want, but you know from your basic negative multiplication rules that the only way to get a negative as the product of two numbers is one positive, one negative. So this is all we need to know that m and n are different, because one's positive and one's negative. I said that about 5 times. Problem 100. And you didn't need statement 1. Problem 100. When a player in a certain game tossed a coin a number of times, 4 more heads than tails resulted. So heads is equal to tails plus 4. Heads or tails resulted each time the player tossed the coin. Fair enough. How many times did heads result? So essentially the problem description just tells us that heads is equal to tails plus 4, and that heads plus tails is just all of the tosses. So statement number 1 says the player tossed the coin 24 times. So that's what I just said. Heads plus tails is equal to 24. And so this is enough information by itself to know how many times did head result, because we could rewrite this top equation as heads minus tails is equal to 4. And if you wanted to solve it, you'd get 2 heads is equal to 28. Heads is equal to 14. All of that would have been a waste of time. As soon as you saw that you had 2 linear equations and 2 unknowns, you could have said, I have enough information to solve for any of the variables. Right? This is a 4. Right? So statement 1 by itself is enough. Statement 2. The player received 3 points each time heads resulted, and 1 point each time tails resulted, for a total of 52 points. So, got 3 points for every head. So 3, that's how many points he got for all the heads. Plus 1 point for each tail, so that's how many points he got for all the tails. And that equals 52. So once again, this is providing us with another linear equation. So now we have 2 linear equations with 2 unknowns. I'm not even looking at what they gave us in statement 1. So just using these 2, we have enough information to solve the problem. We could do it the exact same way. This is what you learned in Algebra 1. So each statement independently is enough, or is sufficient, to solve the problem. Problem 101. Well, we've already done 100 problems. 101. Once you get going, these get kind of fun. 101. If S is the infinite sequence, S1, okay, so it's like S1 is equal to 9. S2 is equal to 99. S3 is equal to 3 nines. I get it. And the kth S is equal to, right, 10 to the k minus 1. Right? This is the third one. 10 to the third is 1,000 minus 1, which is 10 squared is 100 minus 1. Right, so it all works. All right, that's what they told us. Is every term in S divisible by the prime number p? Divisible by p. Well, it depends what p is, right? And frankly, if just the first term is divisible by p, all of them are going to be divisible by p. Why is that? Because all of the terms are divisible by the first term, or 9, right? So if p goes into 9, it's going to go into all of these terms because 9 goes into all of them, right? So we just have to say, does p go into 9? It's a much simpler way of thinking about the problem. Statement number 1 says p is greater than 2. So does every prime number greater than 2 go into 9? Well, no. 5, 7, these don't go into 9. 3 goes into 9, so we still don't know whether p goes into 9. Statement 2. At least one term in the sequence S is divisible by p. At least one term. At least one term divisible by p. If we knew that it was this term, if we knew that the first term was divisible by p, we would be all set, right? But we don't know whether it's just the first term. For example, p could be 11. What if p is 11? If p is 11, then it goes into this term. It goes into the 99, but it won't go into the first term. It won't go into 9, right? So, 11 is an example where it holds for case 2, but it doesn't hold for the whole question. It's not divisible into every term. Or we could say that if p was equal to 3, well, of course, that'll go into everyone. So statement 2 by itself actually doesn't help us any. And actually, both of these numbers satisfy both statements. And so if you pick 11, it doesn't work. If you pick 3, it does work. So both statements combined still do not give us enough information. Problem 102. I got to do some drawing. Okay, so I have a quadrilateral here. Let's see, that's RU. And then go up there. And then go flat there. And then come down like that. And then they draw an altitude here. Alrighty. Okay, so this is an R. This is a W. This is a U, a T, and an S. They're saying the height of this is 60 meters. This length is 45 meters. And they're saying this right here, this length is 15 meters. Fair enough. Okay. Quadrilateral RSTU, shown above, is a site plan for a parking lot in which side RU is parallel to side ST. Okay, so this and this are parallel. What is the area of the parking lot? So immediately, I can figure out the area of this triangle, right? Base times height times 1/2. So I can figure out this area immediately. I can immediately figure out this square region right here because I know it's 60 by 45. And so the question is, can I figure out this triangular region right here? Well, I don't know what this distance is. If I knew what this distance is, then I could say base times 60 times 1/2 and figure this out. So this right here is what matters. That's the crux of the issue right there. So statement number 1 tells us that RU is 80 meters. RU is equal to 80. I think this gets us there, right? Because think about it. If this whole thing is 80 meters, if that whole thing is 80, I can figure out that. How can I figure out that? Because I have 15 here. I have this length is 45. So this length is going to be 80 minus 45 minus 15. What is that? 60. So 80 minus 60. So this will be 20. And so just with statement 1, I can figure out this length right here. And I'm done. Because this triangle is this base times this height times 1/2. This rectangle is this base times this height. And then this triangle is 20 times 60 times 1/2. So I have enough information to figure out the area just with statement 1. Now statement 2. TU is equal to 20 square roots of 10 meters. TU is 20 square roots of 10. Well, this is enough information too. Think about it. This is a right triangle right here. This height is 60. And remember, if we can figure out, let me switch colors. If we figure out the base, we're going to be set. So we could do Pythagorean theorem. So we could say the base squared plus 60 squared is equal to this number squared. And that number squared is what? 400 times 10, right? 400 times 10, so it's 4,000. So you get b squared is equal to 4,000 minus 3,600, which equals 400. So b is equal to 20 again. So this actually also gives you the information that this base right here is equal to 20. And then, like I showed in the previous statement, that's all you need to figure out the area of the entire parking lot. So statement 2 alone is also sufficient. So either of these statements alone are sufficient to tell us the area of the parking lot. See you in the next video.